Our topic for today, it's IT infrastructure architecture. It will talk about the infrastructure building blocks and concepts. This is the first part of today's. As you know, this is the one of the layer from the form that we studied for the compute in the infrastructure mode. The compute, it's, let me just, as you see from the screen, that here the compute section. Okay. Now with the compute here, we will talk inshallah about the compute part. What does it mean? So it mostly will focus on the hardware or the tools that we are using, even for the personal or for the servers. Most of the contents for today's lecture, it will focus inshallah on the let me just accept those students who arrive late. Please guys, try to be on the time, because some students, they are delaying us from start. Okay. The compute, as we mentioned, it's one of the main parts for this course. We will mostly focus for servers. We will talk about servers. What do the company's network or the large networks needs from devices or tools? As you know, they are not consist only from PCs or routers. No, there are specific tools or hardware that have been designed for the network. The servers, they have their own specifications. It's not similar for the normal computers. The processors, the size of the server, if we are talking about the x86 servers or the mainframe or whatever, and what's the purpose from each of them. Also, instead of talking about purchasing the hardware or tools, we will think also about what's the alternative tools that we may use the network to the network to be to save the money and have the ability to do the tasks or the future work on the network. So the compute, it's an umbrella term. It's as seen from the definition here. It's an umbrella term for computers located in the data center that are either physical machines or virtual machines. So from the concepts that if we are talking about computers, servers, we have to understand that there are two categories. There are something physical, that which is it hardware that we purchase it from the market, or a virtual machine. Virtual machine, that means that we purchase an application, or we develop the application, or we use the method to act a real or a physical machine. For example, I have a big server, and then I will use the images for it. Another example, in our college or university, if you are looking to the labs, you will select one image from the the existed ones. If you select, for example, the Unix or Mac or whatever, this means instead of offering a real Mac environment, we are using an applications or virtual machine that have been created, and all the needed applications that already installed on it. Then it facilitates for all students to reach different resources from one place instead of having different places. Okay, what's the physical computer contains normally? Normally, the computer contains. Normally, the computer. Just a second. Okay. Normally, the computer consists of different items, or let me say, tools inside it, such as the power supplies, the central processing unit, the CPU, basic input output systems, keyboard, mouse, screen, whatever. Also, we have a memory, expansion ports, network connectivity, keyboard, mouse, monitor, etc. Those are the physical computer content or tools that are used to within any computer or the usage of the computer. Now we will talk about the classifications of the servers or computers. Here we mention, as if you read here, in general, compute systems can be divided into 3 groups: mainframe, this is 1, and mid-range, this is 2, and x86 servers. So we are talking about the 3 categories of the computers. The first one, which is the large one, mainframe. We call it mainframe. This is the large one. There are limited number of the mainframes around the world. For example, one IBM has one. Here in Saudi, we have one mainframe called Shaheen. There is a Shaheen mainframe in Coast, مدينة الملك عبد العزيز للعلوم والتقنية أو Coast, جامعة الملك عبد العزيز للعلوم والتقنية. موجود عندهم شاهين سيرفر. مدينة الملك عبد العزيز also they have a server. هذا الآن server شاهين. إيش الفرق? What's the difference between Shaheen and other servers? It is a huge, like one room or maybe 2 rooms together. It contains a lot of processors, a lot of, let me say, hard disks, let us call it storage system, a lot of storage systems. They are able to do a lot of processing in 1 second or less than 1 second. Billions of processing to be done during 1 second. What's the purpose or why we are needing those huge computers? We call them mainframes. Mainframes, sometimes they are to be used in the tests, such as the nuclear system or weapons. They are developing those formulas or those calculations virtually on those servers. So mostly this server used to analysis a huge data to get a results, to discover the diseases. For example, in COVID-19, one of the method that assists to exist, it was the mainframes. All the aspects, all the data have been set or entered, and then they run or they compile it by using one or 2 or maybe 3 algorithms. Also, the mainframes support to run different applications at the same time. For example, here I'm doing analysis. In the second processor, I'm doing drawing. I'm drawing some charts, graphs, whatever. This one, the another process may do another processing. We call it multitasking with this part. For example, I have a huge data. This data has been divided. One data goes to the first processor, the second data goes to the second processor, and etc. So this is the purpose of the mainframe. The mid-range system, those are servers which are commonly used. For example, in the banks, they have their own server, which is connected to different x86 servers in different locations. So the mid-range server or system, it's between the x86 servers and the mainframe. It's used in the most, in some companies, banks, universities, not small companies. I'm talking about the huge companies around the world. For example, Nissan, there are a lot of branches around the world. So all of them are connected to one mid-range server. They have a server in Saudi, which is at x86, or different locations, and this is the mid-range server existed in another city. And then the normal ones or the popular ones, x86 servers, which are located in most of the companies or organizations. Even in our university, we have several x86 servers, and in the companies also, they have their own future servers. We are not talking about PCs, because PCs, it's small ones, and we are talking about the servers which are serving the network. So there are three categories. We can call them mainframe, mid-range system, and x86 server. The word, as written, we will read it very quickly here. It's written there, originally the word computer was used for a person who did manual calculations. So the main purpose of computers was to do calculations in 19th. The first computing machine was or were mechanical calculators. Computers are known as computers as we know them now have two specific properties. They are calculate, they do calculations. Also, they are do programmable things. You can program by using the gates or NOR. The first computer in the world, we call it ENIAC, electronic numerical integrator and computer. This was the first computer which existed, and it was designed based on the vacuum tubes. This picture, it's an example of that computer. We will talk about the servers. How can we put the servers in the mid-range? Now we are talking not the mainframe, not the x86. No, we are talking about the mid-range computers. And to store the servers or the data centers here to save the data, there are two classifications, and focus on that one. This came in the exam several times. There are two different type of installation or for the servers. x86, there are two kinds in the mid-range systems. The first one, we call it rack mounted, which is shown in the picture. The servers or the hard disk, it's fitting as in the horizontal way or shape. The blade servers are connected as a vertical shape. هذا بشكل أفقي وهذا بشكل عمودي. طيب, what's the difference؟ طبعا هذا الشكل وفر أمور كثيرة. يعني هذا كان الشكل, it needs one electricity power for each. Also needs a fan for each plate. Need a capacity. But with this style, we may use one plugin and connect those ones on the same electricity power. So no more power supply to be existed. We may add one in each level and two here, for example. Also, the fan, we can install one fan on the back, which is cooling the whole data centers here, or the components. So, and also there are a lot of features, we will cover them. So just to know, this is, we call it rack mounted, and this is the plate servers. The plate servers, one of the, let me just before explaining that, there was one question in the final exam last year, mention 2 or 3 differences between the rack mounted and plate servers in terms of computer housing. Remember that. So you have to list the 3 differences. The first one, plate servers are less expensive than rack mounted. The second one, they shared in the rack mounted, or sorry, in the plate server, they are sharing the power supplies and fans. Also, A plate enclosure typically hosts from 8 to 6 plate servers, shared redundant power supplies, backplane to connect redundant network switches to connect the plate Ethernet, redundant SAN storage. We will explain it in another lecture deeply, inshallah. This one kind of storing the data and the servers. Redundant SAN, storage area network switches to connect the host bus adapters, interfaces on the plate servers. A management module to manage the enclosure and the plate on it. Those are the specifications of the how can we fit the storage or the SAN storage area network on the network. Notice those are the storage. In the vertical, this is old one, and this is not old one. This is more expensive. This is cheaper, or less, not cheaper that much, less expensive than the rack mounted. The plate also, it comes in a vertical ways. This is horizontal ways. It shared the supplies, the power supplies, the fan together here, but here no. So those are the differences, or three differences, the main three differences between the plate servers and rack mounted servers. Okay, we will come to the processor. Processor, most of you, they are know the processor. We call it CPU, Central Processing Unit. It do two things: logical, the basic arithmetic, logical, and control input and output. Operating specified by the instructions. This is the piece of the processor, and this should be taught in the introduction to computing in the first course. We will see just a YouTube sketch that explains how does the processor work, and then inshallah we will continue the lecture. Let me just share. Okay, just see what's inside the processor to know how is that processor be created, and also to keep in your mind that any server, or if we are talking about servers, we are talking about a lot of processors, especially with the the mainframes or mid-range frames, that we are talking about a lot of processors that are existed, not only one processor. Okay, and let us see how is it built and how does it work in this short sketch.
Every computer is a central processing unit, and inside every CPU are small components that carry out all the instructions for every program you run. These components include AND gates, which only allow electricity to flow to their output wire if all their input wires are on. The AND gates use tiny transistors to control the flow of electricity to the output wire. The electricity from another part of the computer flows in from the top and gets stopped at the first transistor unless its input wire is on. When that input wire turns on, it causes an electric field to form around a small piece of insulated metal. This electric field reaches out past the insulation and causes the properties of the semiconductor material below it to change, turning a small part of that semiconductor into a full conductor, bridging the gap for any electricity flowing in from the left and out to the right. The types of components you create from transistors are based upon how you wire their inputs and outputs together. If you chain them together so that the output of one flows to the input of the next, then you are creating an AND gate, where all the input wires must be on for the final output wire to be on. Inside the Scott CPU, you'll see a number of these AND gates scattered around, with some having more inputs than others. Another type of component that you'll come across is the OR gate, which is represented by this shape. Instead of chaining the output of each transistor to the input of the next, you instead run all the output wires to the same place, the output of the whole gate. In this way, if any of the transistors have their input wire on, then electricity flows straight through them to the gate's output. You'll also see a number of these OR gates scattered around the Scott CPU. By the way, the Scott CPU comes from the book How Do It Know by John Scott, which is available at his website, buthowdoitknow.com. It includes a great explanation of how computers work for beginners, and John was kind enough to allow his CPU designed to be used in this video. The other basic component you'll see in any CPU, including the SCOT CPU, is the NOT gate. The NOT gate uses a transistor to divert the electricity already flowing to the output of the gate to a ground wire, effectively short-circuiting the output wire, turning the output of the gate off if the input wire is on. There are a number of these NOT gates inside the SCOT CPU, not only in the locations seen here, but also inside the other components. For instance, the stepper component is just a particular combination of AND, OR, and NOT gates where the output wires turn on in sequence each time the input wire to the stepper turns on. This input wire comes from another small component called the clock, where the output wires turn on and off again very quickly in a steady pattern. The only other component used in this part of the CPU is the selector formed from another combination of AND, OR, and NOT gates that turn on one of several output wires depending upon what input wires are on at the moment. In another area of the CPU is the arithmetic logic unit, which includes more AND, OR, and NOT gates, along with the selector component that we just saw. There are a few other components in the ALU, like the exclusive OR and the NOR gate, but these are just made from the same OR gates we saw earlier, along with some AND and NOT gates. In other videos, we'll see how these components work together to process instructions sent to the CPU. This has been a brief look at what's inside the CPU.
Okay, we have seen that the processor from inside, and we shall know. Just a second, okay. Okay, and we shall know that inside that processor, here a lot of gates have been, or billions, millions and billions of gates have been included inside that small chipset. يعني الجيتس الآن والأور or a lot of them, they have been existed there. If you are seeing the processor i2, i3, Core 1 or Core i7 or i5 or i3, this means the processor, it has been divided for layers. Let us call them layers. It's just this to clarify the concept. So, which is, it means that like similar for merging two processors together. So, in order to avoid the increasement of the size of the processors, now the new technology which existed in 2004 at that time, or 2003, they classify, or they created or they built the processor as a layer. So the first layer, it will consist of the gates and etc. And then they put specific materials to protect that layer, and then they created another, which is similar for another processor on it, and this is what they call it I2. And then they existed a third layer, they call it I3, until 7 layers or 9 layers. So they are saving the same size, but they are merging different layers on them. This technology or this techniques saved a space from the motherboard. Also, they increase the the opportunity to expand the processor. But but one question may be asked: how can we measure the speed of the processor? From the YouTube sketch that we mentioned, there was a clock. Exactly, it was there. This clock, it's to make the liveness of the processor by running the gates per second. How many processes done through a second? This is we call it a speed. So there is a frequency, how many processes that should be done in the maximum, and the lowest one in during 1 second. So the speed, it will be measured because we have a frequent clock that is running. We measured or we are using the hertz to measure the speed of the processors. So keep in your mind that if we are talking about your speed, 1 giga, 2 giga, 16 giga, 32 giga, gigs, whatever. We are mentioning gigahertz. For example, here 2.4 gigahertz CPU can perform 2.4 billion additions in 1 second. This is the speed of the processor. Okay, now we will move to the memory. We finished the processor and we will talk about the memory. The memory, the first memory, it was built in the vacuum tubes. You can just log into the internet or YouTube, mention that the vacuum tube, how it looks like. Vacuum tube, it was the first tool which is similar for the light. قديما نفس المصباح أو النور اللي يركب في الجدار الفر مسحوب من الهواء. So for that reason we call it vacuum tube. It saves the time. طبعا تحفظ كهرباء فيها. إذا حفظت معناته هذا واحد. لم تحفظ صفر. The main disadvantage for the vacuum tube, it's easy to be broken and it's quickly to be damaged. بسرعة تتعطل وتتكسر لأنه مصنوع من الزجاج النقي وتسبب حرارة. So it was and also the size. So the first computer, it was the capacity of that PC or ENIAC. It was similar for a house in our today's likeness. So the alternative vacuum tubes, the specifications of it: mechanical parts uses magnetism to move physical switches. 2 layers can be combined to create a single bit of memory usage. And also it was slow, use much power, and noisy, heavy, expensive. But this is all of them, they have been gone. And that stage, another technology that have been existed in the 1951, they call it magnetic core memory. تعتمد على نفس خلينا نقول الكاسيتات القديمه اللي ما ادري انت لحقتوا عليها ولا لا. قبل السي دي كان في كاسيتات قديمه ماجنت. it was involved. ممكن تاتي على شكل كديسكات بالشكل هذا او ككاسيتات كبيره to demonstrate the memory, to save it. It uses very small magnetic range called cores with wire running through them. The wire can polarize the magnetic field one direction or the other in each individual core. One direction means 1, the other direction means 0. So it was like that style, 1 or 0. Okay. But this was better than the vacuum tubes. Then we moved to the current one. We know that after the magnetic, let me say, memory, we moved to the RAM. So the RAM, it has been created, which is a chips that installed in the motherboard. قطعة تركب في المotherboard, we call it RAM. Even in your mobile phone, it has its RAM. RAM, any piece of data stored in RAM can be read in the same amount of time regardless of its physical location. أي بيانات تخزن في الرام يمكن قراءتها. طيب متى بتختفي؟ إذا قطعت الكهرباء عن الرام. If I disconnect the electricity from the RAM, all these data will be gone. If I increase the RAM, the speed will be increased. If I increase the speed of the RAM, the speed of the computer will be increased as well. Based on the transistor technology typically implemented in large amount of integrated circuits, data is volatile. It remains available as long as RAM is powered. يعني بمجرد وجود الكهرباء بيستمر unless we disconnect the electricity, the data will be gone. There are 2 categories or 2 kinds: static RAM, dynamic RAM. Those are 2 techniques of designing the RAM: static RAM and dynamic RAM. Let us watch that sketch from YouTube. It will show you how they have been designed and what's the difference between them, and this will assist us to understand this slide and the figures or the points that have been mentioned. Just let us watch the sketch from YouTube as well. Okay.
That's what RAM is and the role that it plays. In this video, I will be going a bit more in depth into this component, explaining precisely what, why, and how it does what it does by going into the two main subcategories of RAM, dynamic RAM and static RAM. To give a brief refresher, RAM is a bit of a middle ground. Hard drives are very slow but store a ton of data, while processors are extremely fast but store hardly any data. Random access memory is a mixture of the two.
Just focus that we have hard drive, CPU, processor. Processor is very fast, but poor space. A hard disk, a good space, or great space to save, but poor speed. It's not the speed of the hard disk. It's not similar for the CPU. So we existed the RAM, which is it between the two. It's a speed lower than the CPU, but it has it can process the data quickly. Also, it can save more than the processor from the data. Okay.
A place for large, bulky data and machine code to be temporarily stored so your CPU can grab it and use it faster than the hard drive would be able to provide for it. So let's take a look at the two types of RAM, static RAM and dynamic RAM, often referred to as SRAM and DRAM respectively. Every stick of RAM that you buy is going to have a little bit of both, as they're intended to work synergistically. Here are the main differences between the two from a functional perspective. Static RAM stores less data, while dynamic RAM stores more. Static RAM can be accessed much faster, and dynamic RAM can be changed much faster. Dynamic RAM costs less, and dynamic RAM uses more power. Now let's talk about how each of these work, and then I'll get into the types of things each one is used for. Dynamic RAM stores binary data by using one transistor and one capacitor for each bit.
طبعا عملية التخزين حتى تكون في الصورة هي عبارة عن إشارات كهرباء. إشارات كهرباء للتخزين. في حال وجود إشارات الكهرباء معناتها هذا الآن التخزين. أو عن طريق الجيتس.
As I mentioned in my video on binary, this code of ones and zeros is what all data and instructions come down to. In dynamic RAM, if a capacitor is holding a charge, it's a 1, and if not, it's a 0. The transistor connected to this capacitor lets the rest of your computer know if the capacitor is charged or not, and it also allows it to be changed as requested. Think of the transistor as what controls what is stored, while the capacitor is where it is stored. The advantages of this are that the transistor and capacitor put together are incredibly small, allowing for millions of them to be present in an area the size of your finger. The problem with microcapacitors is that they lose their charge very quickly. They can only store it for a few milliseconds, and this means that in order to remain charged, the capacitor must constantly be refreshed with tiny bits of electrical current. This results.
طبعا هذه العملية بما أنه مرور كهرباء يحتاج عملية ريفرش إنه كل شوي يغذيها كهرباء حتى تبقى أكتف. أي مرور كهرباء يسبب تسخين. لذلك تجد أغلبها مغطى بطبقة من الألمنيوم to cool it من أجل تبريده.
Results in memory that can't be accessed quite as fast as it could if it were in a constant state. But because this type of memory is constantly refreshed anyways, it makes it easier to make changes in a state from on to off. Now let's take a look at how static memory works. Instead of using capacitors, static memory uses only transistors. But it requires 4 or sometimes 6 of them in order to represent.
طبعا تستخدم 4 أو 6. في السلايدز عندكم مشير يقول إن 6 ترانزستورز موجودة فيها. استغنى عن الكاباسيتور اللي هو يحفظ إشارة كهرباء واستخدم إن كل 6 تمثل بت أو 4 في بعض الرامات على حسب التقنية أو التصميم.
And one single digit of binary and therefore 1 bit of data. Static RAM accomplishes this by using something called the Boolean method, which is too complex.
طبعا كيف تحفظها؟ عن طريق استخدام Boolean method. يعني بمجرد مرور الكهرباء يعرف إنه 1 أو 0 باستخدام Boolean method واللي هي تعكس كيف إنه يبتي 1 أو 0. Boolean method اللي هو and or nor اللي أنتم درستوها.
To get into now, but I'll make a video on it in the future. In short, because static RAM requires more transistors to represent a single bit of information, it obviously requires more physical space on your RAM chips in order to do so. This results in less storage space. The advantages of this method is that unlike capacitors, static memory is constantly in the state that it's in. Whether it's representing a 1 or a 0, it remains that way and can be read that way until it's told to change. And this means that it can be accessed much faster than dynamic RAM, which sometimes has to wait for a refresh before it can be read. So we have a high capacity, easy to change, but somewhat slow system of memory, and a low capacity, harder to change, but instantly readable system of memory. Why are both necessary, and when is one used rather than the other? As you may have guessed, static RAM is used to store data or instructions that aren't particularly large, but need to be accessed frequently and quickly, such as a cache. Meanwhile, dynamic RAM is used for everything else, things that aren't needed quite as urgently or frequently, but take up more space.
Just focus on the last things that he mentioned. ذكر نقطة مهمة، قال الآن الإسرام اللي فيها كابستر يقول لك الآن things that are small، أشياء عمليات صغيرة ما تحتاج كبيرة وتحتاج سرعة، but it's important، يفضل استخدام الرام. ما عدا ذلك دي رام زي ما هو معمول عندكم الآن لابتوبز والأشياء هذه ذاكرة دي دي ار دي دي رام whatever what's اس دي رام على حسب النوع اللي انت تحتاجه، ولكن الإسرام things that are small but important, which is it using the pooling methodology for the DRAM. Okay, let's go back to the slides and we will explain the differences. As we've seen from the YouTube, that we now able to know that in the static RAM, okay, in the static RAM uses flip-flop circuit to store bits, 6 transistors per bit. We mentioned in the YouTube 4 or 6 transistors per bit. This is for static RAM. Dynamic RAM uses a charge in a capacitor. It needs electricity, 1 transistor per bit. So here we are having 6 transistors, but here we have only 1 transistor plus 1 capacitor. DRAM loses its data after short time to the leakage of the capacitor. تفقد بياناته بسرعة ولكن تحتاج انك وجود كاباسيتر. To keep data available on DRAM, it must be refreshed regularly, typically 16 times per second. Okay, now we will come to another kind of the storage. We call it we call it BIOS. The BIOS basic input output system. The BIOS, it's a piece or chips that installed already in the motherboard. The functionality or the purpose of this piece or chips, it contains instructions that run the PC from pressing the start until the operating system run. احنا عندنا لما نشغل جهاز نضغط زر التشغيل اللي موجود في الجوال او خلافه وتظهر لك علامه الايفون سامسونج او اللابتوب ديل وريفر. خلال العمليه هذه حتى يظهر نظام التشغيل ويندوز او الاندرويد، the BIOS is running those ones. The main task of the BIOS is to make sure that all devices are connected, the hardware are connected and working perfectly, and it will contain the system files that running the needed code or applications to start the operating system. So the BIOS controls the computer from a moment of board on to the point where the operating system is started. Mostly implemented in flash memory chips. It's good practice to upload the BIOS software regularly. So most of the updates for your computers, one of them, it shows you that the BIOS needs to be upgraded. It is recommended always to upgrade the BIOS. Some viruses now, they are attacking the BIOS. If they are attacking the BIOS, it will damage the BIOS, then the system will not run. If you press the on button, it will not work. You will hear a voice. So what in that case, you need to reflash the memory again by using the USB or specific devices to reprogram it again. Okay, now we will talk about the interfaces. Interfaces, just to simplify the contents, if you are looking to your computer or PC from the back, you will notice some ports. هنا مثلا تكون USB، هنا تركب الشبكة، هنا ممكن تركب شاشة أخرى، سلك HDMI whatever. هذه الآن القطعة تراها من جهازك في الخلف اللي تركب فيها الأسلاك. Those are, we call them in simple word, interfaces. Okay, so interfaces connect computers to external peripherals is done using interfaces. External interfaces use connectors located at the outside of the computer case. One of the first standardized external interfaces was the serial bus based on RS-232. هذا الآن الكابل حتى ممكن يستخدم، تجد بعض الأماكن الآن is still used today in some operating systems. السبب لوجود أدوات قديمة قد تستخدمها industrial equipment, console port, specific purpose equipment to program a router, whatever. So you will use one of the we call it COM1 or RS-232. This is a serial port that is existed already in most of the computers, which is it used for programming. And then those connectors have been designed to be USB convert the technology of linking devices completely. It's a universal serial bus. It has been designed in 1996 and it has been developed yearly. And can provide operating power to attach devices. Up to 7 devices can daisy changed. In 2013, USB 3.1 was introduced. It's able to handle or to deal with 10 gigabits per second. So the speed, it has been increased. In 2014, Type C was developed or introduced. Type C, there are a lot of speeds. It could be 20 watt, 30, 45 watt, until hundreds of watts. التايب سي سريع جدا، هو الآن تقنية تقريبا خلينا نقول اللي موجودة سريعة جدا في عملية نقل البيانات. There is another one اسمه ثندر بولت، يأتي مع الشواحن صورة علامة برق، هو تايب سي. الكونكت يأتي بشكل سي ولكن تأتي العلامة هذه مع in your computers like an thunder arrow، يأتي سهم على شكل برق. This is the Thunderbolt cable. It comes as a USB cable but with more speed and also it can deliver 40 gigabits per second and it can deal. طبعا ممكن يشحن الأجهزة ب 100 واtt power of devices. يعني بعض الكمبيوترات لما إذا أنت ركبت بالسلك منخفض السرعة راح يتعامل مع منخفض السرعة. التايب سي ليس فقط مجرد سلك، إنما يأتي بسرعات مختلفة. نفس الشواحن، لما تشتري شاحن سلك تايب سي لا تتوقع أن كل تايب سي نفس الشيء، لا، اسأل كم واط ينقل. بعض تجد التايب سي يقول لك أنا هذا والله يتعامل مع مثلا 15 واط أو 10 واط. This means the maximum speed that this cable can deliver it's 10 watt. بعض الكابل يقول لك لا هذا يتعامل مع 20، هذا بعضه مع 65، هذا يتعامل مع 100. So if the 100 طبعا يعطيك super fast charging، ممكن يحرق الجهاز إذا أنت أخذت شيء أكبر من البطارية. يعني بعض الأجهزة يقول لك الماكسيمم مثلا 60 أو 65 watt and if you are using 100 watt to run it you may damage it. Some computers are supporting this kind of charging or data transferring, then you can use it. How it looks like? It looks like as a USB نفس Type C، نفس cable Type C ولكن عليه صورة برق. This is, you can find this port in your PCs or in your devices. I have one here actually, but I can't take a picture of it. Okay. نأتي الآن للمنافذ PCI. We have two things, PCI and PCI extended or express. PCI Express and extended. We will skip, not to skip, we will take this slide and this slide by watching that, the YouTube sketch, which is to give us a clear definition and comparison between the PCI and PCI Express. To keep them understood, in the motherboard you will find those PCIs. الشكل هذا PCI، هذا القديم. هذا الآن خاص بالرام. PCI 16, this is for RAM and or other cards. بعد بدأ التطوير PCI Express في بالشكل هذا وفي بالشكل هذا، ممكن يأتي شكل آخر. So we will see a full details information by watching that YouTube sketch, inshallah, which is it summarize what we are looking to reach on this content. Just watch it.
Questions about PCI Express. What works with what? What doesn't work with what? What are the different generations? What does it all mean? So today we're going to tell you everything you need to know about PCI Express.
طبعا حتى بس تكونون في المعلومة، هذه الانترفيسز، الجزء هذا اللي موجود عندي أنا شرط، هذا الانترفيسز، هذه أشياء ظاهر للشاشة، ظاهرة لك للمستخدم في الخلف، هذه انترفيسز. وهذا الآن القطع اللي داخل الجهاز، هذا we call it PCIs. الPCI أو PCI Express. Okay.
Express 3.0 as fast as possible. So let's start with the very basics. PCI Express is the interface that is used to plug modern expansion cards into modern computers or motherboards. It completely replaced PCI and AGP, which is great because AGP was only for graphics cards and PCI had to be used for pretty much everything else. PCI Express works with pretty much anything. Sound cards, network cards, RAID cards, video cards, they'll all pretty much fit as long as you're aware of a few simple guidelines. Now, I said they're universal, but PCI Express slots are available in a variety of different physical configurations. The most common ones are 1x, 4x, 8x, and 16x. All of
ركزوا على الأرجل اللي موجودة هنا، يعني هو ذكر الأنواع مرة أخرى.
The most common ones are 1x, 4x, 8x, and 16x. All of these types have different slots on the cards themselves and different slots on the motherboard. The cool part about that is that they're upwards and downwards compatible though. Here I am plugging a PCI Express 1x card into a 16x slot. It gets the same power delivery, it just gets less bandwidth delivered to it because that's all a sound card actually needs. And not only that, but I can take this PCIe 8x RAID card and plug it into a PCIe 4x slot. It'll still work, but it will only have half of the bandwidth available to it that it would have otherwise had if you plugged it into an 8x slot. The other thing that
هنا ذكر نقطة علشان عدم استخدام، يعني إذا ركبت مثلا جهاز خلينا نقول سريع جدا وضعته في بورت منخفض، سرعة الجهاز أو الكرت اللي ركبته تنخفض لأنك مركبها في بورت مش سريع أو مش نفس السرعة اللي يدعمها. بعض الأشخاص يشتري، وهذا حقين الجيمنج، يشتري كروت شاشة مثلا جدا مواصفاتها عالية ولكن يركبها في المذر بورت في بورت مش مناسب، يجد أن الكفاءة يقول ما فرق معي شيء. لذلك you have to make sure that you are plugging the card in the correct PCI and make sure that your motherboard is supporting that speed from the VGA card. You have to focus on that point.
that affects the performance of PCI Express is the generation. Here I'm holding a PCI Express Generation 2 16X card, and here I'm holding a PCI Express Generation 3 16X card. They look physically the same on the connectors, but the actual available bandwidth has doubled. In fact, the available bandwidth of PCI Express cards has doubled with each generation. So a PCI Express Generation 1 16x slot is only equivalent in performance to a PCI Express Generation 3 4x slot. So the takeaways from this are pretty straightforward. PCI Express cards work in PCI Express slots as long as there's nothing physically in the way. Performance, on the other hand, is going to be dictated by what generation of PCI Express the card and the slot are running.
يقول لك تأكد هنا باختصار. You have to make sure that the VGA, which version, which class, if it's 16, 32, 8, whatever, then and it should be suited for the motherboard slot as well.
So it'll run at whatever is the lowest generation of either of the two components. So Gen 2 card, Gen 3 slot, plug them together, they run at Gen 2. And then performance is also determined by the length of the card and the length of the slot. So for example, this quad port gigabit NIC needs at least 500 mega.
طبعا اللي بيده هذا كرت شبكة ممكن يدعم. طبعا قد يكون في بعض السيرفرات يأتي نفس كرت الشبكة هذا كان يعطيك 4 كروت شبكة مركبة في جهاز واحد. أنت في بعض الشبكة مرات يكون عندك التواصل ما بين جهاز وجهاز آخر. يفضل عندك طبعا في السيرفرز that you have for example 4 network interface card. So you will plug that card which is it assist you to run different interface card in your server to make the connectivity always, let me say, حتى تبقى الاتصال لو تعطل واحد فيهم so the others are running the process.
Gigabytes per second of bandwidth in order to operate at peak efficiency. That means if I have an older PCIe Gen 1 motherboard, I'll need at least a 4x slot or a hypothetical 2x slot to get the bandwidth I need because it's only 250 megabytes per second in a 1x slot. However, if I have a PCI Express Gen 2 motherboard, I could even use a 1x slot to get everything I need because that'll be about 500 megabytes per second. Thanks for checking out this episode of Fast.
Okay. This is that YouTube sketch gave us a clear, clarification about. Okay, this YouTube. Okay, just a second. Okay, now. Okay, this give us explanation about the PCI. The PCI Express also, it shows us most of the informations here and we know now what's the difference between them. Also, we mentioned the differences on that screen. Computer virtualization. دائما, as I said, كلمة virtualization means something virtual, not physical. Computer virtualizations, حط في بالك أن نستخدم applications that we are using applications, layers, we are using applications to create layers to divide the resources of the that we have, the physical resources that we have, to be in a group or to be as a virtual machines that are running different tasks in different times with different users. يعني كان الآن بدل لا أنشئ كلمة virtuals لما أقول compute virtualization كأني أقول أنا عندي أجهزة physically موجودة أبدأ باستخدام البرامج معينة أقسمها كأنه virtual machines كأني أعمل simulation للسيستم to act that I'm having more than one servers. يعني ممكن يكون فعليا عندك سيرفر واحد باستخدام برامج معينة كأنك تحاكي إنه عندك أكثر من servers وكل servers it has its own operating system. For example, if I have one server, by using the virtualization layer, I can create different virtual, by using the virtualization layer, I can create different virtual machine, and each virtual machine has its own operating system. This could be Windows, this could be Mac, for example, and could be Linux or Unix. So this is the benefits of using the compute virtualization. Servers, we can virtualize the server or software SDC by using software-defined computing. Introduced abstraction layer between physical. We have to introduce virtualization layer between the physical machine and the virtual machine. Allow multiple operating systems to run as a single on a single physical machine. Again, allows multiple operating system. هذا الفائدة حق الكمبيوتر virtualization. It allows multiple operating systems to run on a single physical machine. Also decouples and isolate virtual machines from physical machine from other virtual machine. So this is alone, isolated. There is no link between this one and this one and this one. So this is the benefit of compute virtualization. And we'll see YouTube sketch that explain how it looks like, and we'll continue, inshallah, after this slides. A virtual machine, it's a logical representations of a physical computer and a software. It's clear. New virtual machines can be provisioned without the need of hardware purchase. You can design it, or you can create it, or you can simulate it without the need of a hardware purchase. No need to buy those hardware. By the application will assist you to act the functionality of those hardware. With a few mouse clicks or using an applications. New virtual machines can be installed in minutes. Cost can be saved on hardware. Cost can be saved on hardware, power, and cooling by consolidating many physical computers as a virtual machine on a fewer bigger physical mechanics. Because fewer physical machines are needed, the cost of maintenance contracts can be reduced. بما انك قللت الاجهزه الهاردوير، الكونتراكت لصيانه القطع الهاردوير راح يقل بسبب انه عدد الادوات عندك قلت، ولكن تحتاج وجود دعم فني، a team support to assist you with the virtualization process. خلونا ناخذ الان YouTube sketch that explains some concepts, and we will come back to our slides, inshallah. We may watch. Okay, we finished from that one. Okay, we'll talk about the virtual computerization, virtual computing, and then we will move to the SD, the software designing, inshallah, after this YouTube sketch.
The question to answer is why virtualization? Well, it's simple. It saves money and resources. Of course, you'd like us to tell you how it works, so here's a simple introduction. Virtualization, or virtual computing, makes one physical computer act and perform like many computers. Every computer, irrespective of its power, size, or age, from the smallest PC to the biggest mainframe, has 4 attributes. Each one has a processor, the chip that does the work, some memory, the chips that remember.
كأنه يقسم مصادر الجهاز اللي موجودة عندي الآن. The PC that I have now, which there, it means that I'm gonna to divide its physical things to be separately. كأني أقسم جزء من السي بي يو، أقسم جزء من الميموري، أقسم جزء من الستورج ومن الشبكة، وأعملها VM معين. أقول هذا الفي ام وير الفيرتشوال ماشين رقم 1، وهذا الفيرتشوال ماشين رقم 2 and etc.
Remember the task and how to do it. Some storage, which files everything away, and a network connection. Because we rely on computers for every aspect of our business life, there are hundreds of servers, PCs and laptops in most organizations, but they all have the same need for these 4 things. So virtualization works as follows. A big piece of hardware with plenty of power in processing, memory, storage and network capacity is loaded with a piece of software called a hypervisor. The hypervisor is sometimes called the abstraction layer because it abstracts the physical resources and reallocates them more efficiently. In this diagram, above the abstraction layer is a guest computer, or some people call it a virtual machine. These virtual machines are just very big files. The guest computers run inside the physical hardware, which is called the host. An example of how a virtual machine runs inside a computer is the sending and receiving of some data through the network. Sent data leaves the guest computer. It travels through the hypervisor to the network card on the host and forwarded it to its eventual destination. The same works in reverse when receiving data. Why would you do this? Well, simply because you can run many machines simultaneously over one physical hardware. So you can save money on hardware, consolidate management, reduce energy use, and it becomes a much more efficient use of resources. Most computers operate using between only 4 to 7% of their resources. By virtualizing these computers, you can get many guests onto one host. Immediately, you're going to get much greater efficiencies in power consumption, physical space, and energy use from cooling. Of course, you should need less people to look after that equipment. Now, when you need a new server, you don't need to buy new hardware. You can make a virtual one. If you need more memory or CPU on a device, your administrator just changes the resource allocation with a few mouse clicks. So what can you virtualize? Well, anything that has the 4 attributes of a computer. Even the network and the switching between computers can be consolidated onto the same platform. There are more benefits. When you have 2 host servers, then you have the ability to move machines around, so available resources are optimized at all times. It's quite possible to move a powered-on guest computer from one host to another. You might do this because the first host is overloaded, or because there's been a catastrophic hardware failure of the original host. Maybe you can get cheaper processing costs somewhere else, which introduces the concept of cloud computing. However, this flexibility does raise some questions. Where are your machines? Who has access to these systems? How are they managed? What security is in place? Our other videos on virtualization risk management outline...
Okay, those are questions which are actually mentioned for the virtualization that could be considered. We will come back to these slides, and inshallah we will go fastly with some slides because the contents of this chapter is a little bit huge. Okay, so we spoke about the compute virtualizations. To control those virtualizations, we need software-defined compute. So there should be a software that assists us to manage the virtual machines. The virtual machines are typically managed using one redundant centralized virtual machine. So there is one redundant centralized virtual machine that managed these virtual machines. What's the functionalities or this machine can do? Enable systems managers to manage more machines with the same number of staff. Allows managing the virtual machines using the applications, servers. Server virtualization can therefore be seen as a software-defined compute. In SDC, all physical machines are running a hypervisor, as we mentioned from the YouTube sketch, which is the main one. Our hypervisor and all hypervisors are managed as one layer using management software. This is the infrastructure of it. So this is the physical machine. We have the hypervisor for each machine or each server. Then by using the software or the API, we will create different virtual machines that are linked to hypervisors and to be controlled through the virtual machine management. So virtual machine management system, it's a control panel that control the virtual machine copies. يعني اتحكم بنسخ الفيرتشوال ماشينز عن طريق الفيرتشوال ماشين مانجمنت سيستم. هو مربوط دايركت بالهايبرفايزرز ويسمح لي بعملية create أو control الفيرتشوال ماشينز. أي فيرتشوال ماشينز عملية مثلا على سبيل المثال إضافة ابلكيشن معين، زيادة الهارد شو اسمه storage space, network traffic, whatever. Okay. Software, also some virtualization platforms allow running virtual machines to be moved automatically between physical machine. ايش البنفيتس for SDS SDC? When a physical machine fails, all virtual machines that run on the failed physical machine can be restarted automatically on other physical machine. يعني عملية ما راح يصير تعطل، تبدأ تعاد تشغيله مرة أخرى في ال virtual machines. Virtual machines can automatically be moved to the least busy physical machine. Some physical machines can get fully loaded, while other physical machines can be automatically switched off, saving power, and etc. As you know, while there are advantages for the virtual machine or computer virtualization, there are also some disadvantages, such as must be managed. All virtual machines should be managed, should be use resources of physical machines, use power and cooling. لأن بتصير عمليات البروسيسنج عالية تحتاج باور وكولينج. دائما غرف السيرفرز يكون مكيف شغال فيها والتبريد صيف شتاء دائما. must be back up انه توقف تكون كذا واقف. must be kept just I can't see this one. okay, must be kept up to date by installing patches. الشركة اللي طورت لك البرنامج حق الفي ام لازم انك تحدثه اول باول ولا راح يتعطل. we call those updates by patches. okay, introduction of an extra layer of, in the infrastructure. license في اشتراك تدفع عليه الرخصة حقت البرنامج. system managers training تحتاج انك تدرب التيم. عملية الانستليشن والمينتنانس. this is an additional things. طبعا some servers require additional specific hardware. قد تحتاج أجهزة معينة لعملية الربط، سواء كان مثل لوحة مفاتيح خاصة أو كيبورد أو USB whatever. بعض التطبيقات لا تدعم الفيرتشوال ماشين. يعني الآن مثل الأوفيس ممكن يقول لك أنا عندي نسخة مثلا تدعم الفيرتشوال ماشين، وعندي نسخ لا حقت البي سيز تختلف. يعني البي سيز تختلف عن نسخ الفيرتشوال ماشين. so there are some applications يقول لك أنا ما أدعم الفيرتشوال ماشينز. يعني أي شخص يرش الفيرتشوال ماشينز أو المالتي يوزرز كوبي he may not offering a multi-users copy. So not all applications may be fit or installed in the virtual machines also. The virtualization technologies, emulation, which does it mean? Can run programs on a computer other than the one they were originally intended for. Run a mainframe operating system on x86 server. Logical partitions, hardware based using mainframe and mid-range systems also. Hypervisors servers control a physical computer hardware and provide virtual machine with all services of physical. By using those ones, virtual and the three types of them as mentioned from the slides. Now we will come to the concepts of container. عندنا بعد ما خلصنا الفيرتشوال كومبيوتنج في مصطلح اسمه الكونتينر. الكونتينر أو الحاوية. What does it mean? How is it looks like? Inshallah, we will watch that YouTube sketch to give us explanation for several slides, and then we will come back. طبعا مصطلح الكونتينرز قبل ما نبدأ ترى يبدأ عن طريق اللينكس. يعني أغلب السيرفرز الآن يقول لك أنا أقسم المالتي تاسكينج والمالتي يوزرز، يعني بحيث إنه يكون كل يوزر يستخدم الكمبيوتر بشكل مختلف تماما بإدارة عمليات كاملة. أفضل شيء اللي هو لينكس كيرنل. يعني الويندوز ما يستطيع يدعم المالتي يوزرز إلى الآن. حتى الماك أنشئ على يعني اللينكس. So Linux kernel, this is a concept which is it assist us to lead the servers and to develop the contents of the container. What does the container mean? Inshallah, we will see it now. بإذن الله. Okay, we'll see 2 YouTube sketches and then we will come back to these slides.
Yeah, forum. In this 4 minutes video, we're going to learn about containers. You might have seen containers that are used to ship various goods that is transported across the seas using large vessels. What about the code we write? How do you ship that particular code from one machine to another machine? That we're going to learn today in 4 minutes. In the traditional classical deployment scenario, you will have hardware and operating.
Again, المصطلح ترى كل كلام هذا ينطبق على لينكس. هذه الخصائص مش موجودة في الويندوز. في شيء اسمه مصطلح اسمه kernel. We have to know what is it, how is it going, and how does it work.
System where you will run multiple applications, for example, Node.js that has certain dependencies and that needs certain libraries and specific kinds of operating system. For example, if you want to install MySQL, then it needs also some kind of libraries and dependencies and specific requirement of operating system. Similarly, if you are using multiple softwares, each software or application will have its own library and dependency. Sometimes what will happen is there might be a conflict. Some applications need some libraries specific to some versions. Some other application needs a different version of the same library. How do you solve this problem? What you will end up with is a dependency matrix hell where you are unable to easily upgrade.
هنا يشرح طبعا عندك برامج مختلفة كلها عندها مكتبات خاصة. يعني الآن أنت تشغل برنامج عند المكتبات ممكن تبي تستدعي المكتبة في برنامج آخر يعمل بنفس الوقت. يعني مثلا تستخدم الجافا عندك ماي اس كيو ال تحتاج مثلا برنامج معين وقد تستدعي المكتبة أو تعمل أكثر من رن في وقت واحد. في الويندوز ترى مش موجودة عشان كذا ممكن يكون الكونسبت it's not clear that much. You have to think from this mode how the computer can solve this issue.
Or maintain these applications. So how do you resolve this dependency matrix hell when you are maintaining the applications? So containers help solve this problem. Containers help build the application, ship the application, deploy and scale these applications with ease and independently. Let's look at the architecture. Similar to earlier, you will have hardware and operating system. There on top of it, you will have a container engine like Docker. We will learn more about Docker in our next video. So we will have a container engine software that help create containers that packages the libraries and dependencies along with it, so that you can move these containers seamlessly from one machine to another machine without worrying about the libraries and dependencies, since they come as a part of a package, which is nothing but the container. So you can have different containers. These containers can be moved across the virtual machines without worrying about the underlying dependencies that the application needs to run, because everything the application needs to run is packaged as a container that you can move around. So what are the advantages of these containers? Let's look at them. For example, in the traditional scenario, if you want to install a particular application, it is very time consuming. You need to run multiple commands that checks for multiple dependencies, and sometimes you will go into various dependencies.
هذه المقارنة وهي موجودة في أحد السلايدات. Please consider it.
Of the softwares and the conflicts, then you need to resolve it. It's a time-taking process, and you need to repeat the same thing again and again if you're trying to install the same application in a development environment, production environment, staging environment. Containers help solve this problem, since everything is packaged and you can just move it and then run a single command which automatically installs all the dependencies and libraries without conflicting with others. So like we discussed in the earlier slide, software dependencies is a huge issue in the traditional deployment model, since containers help package all the dependencies within the container and isolate it. It is easy to manage in the containers. Also, containers you can move from one system to another system. Containers help packaging the software. and you can easily ship it without any duplicate efforts, and also resolve the compatibility issues. Also, containers helps process isolation so that it's easy to find out what is going on and help improve the security as well. And also, containers are easily scalable. In the traditional deployment model, it is not easy to scale. You can scale these independent containers and have a load balancer or a service which splits the traffic, and you can scale the applications horizontally. So containers offers a lot of flexibility and easiness how you can manage your applications. We're going to learn more about containers and see them in action. Please subscribe to the video channel and get notified if any future videos. Thank you for watching this video. Please like and share this video and help spread the word, and get notified if any future videos.
Okay. We'll watch the second one,
Pass your certification
and then we will come back to it, inshallah.
Between VMs and containers. And you know that this is the overall architecture. So you install an operating system, that's your hypervisor, and it runs multiple VMs. But you pay a performance premium here because you have one kernel here, another one here, and another one here, giving you 3 separate kernels. And by kernel, I'm referring to this distinction between this kernel mode and user mode, where the kernel runs the operating system, and then the user mode are the applications that you're running. Now, we're looking at Windows here, but this diagram essentially applies to Linux too. And here, you can see that with the Linux kernel. Now, once we start talking about containers, things change. First of all, we reduce the kernel down to 1, and you can see that here. And here you could load different operating systems. You could have Windows here and Linux here. But with containers, you always have the same host, the same kernel, and you always boot into the same OS. You just have a bunch of processes on the host. Now, specifically, those processes run inside a container. So what is a container? The container actually holds C groups, namespaces, and UFS or union-capable file systems. Most of the time, a container actually seems like and acts like a particular operating system. And that would be a Linux operating system, although there is some variation. A namespace provides isolation, and it limits what you can see and then what you can use, whereas a C group will limit how much you can use. Take a look at these 2 definitions. C groups provide metering and limiting, as well as access control. Namespaces, again, provide processes with their own view of the system. So there's a separate namespace for PIDs, so the process identifiers for net, mount, UTS, IPC. And this is important. Each process is in one namespace of each type. So in the case of PIDs, those processes can only see processes in the same PID namespace. Go take a look at this example. We have a resource, CPU, and a node, which is a group of processes. Here we're looking at batch, but it could be real time or it could be memory. And then you have your namespaces and the processes inside those namespaces. So notice that Hadoop's 109 and 88 PIDs have no ability to see Bitcoin's 52. They are isolated through namespaces. And notice that their access to resources, in this case CPU, but it could also be memory or others, is being limited by, controlled by C groups. So that takes us through C groups and namespaces. But for UFS, we need to look at the union-capable file system, which is a way of combining multiple directories into one. So for example, if you have a CD-ROM, which is obviously not writable, you can combine it with another directory and provide what appears to be, or the illusion of, writing to a unified single directory. Now, this is related to a container, and in the world of Docker, it looks like this with our kernel C groups, namespaces, and then we have something called an image, which really provides the operating system as the kernel sort of sees it. These all come in what are called layers. They're all read-only layers until the top layer, which is in fact writable. This is known as copy on write, which is described in more detail here. Now, because we're not emulating anymore in the container world, you get what's called a lighter environment that can, in fact, run more hosts than this environment would be able to do. And by hosts, I'm really talking about containers because of the image we just saw a few seconds ago. This sort of architecture is sometimes known as microservices because you'll have one container here, and another here, and another here, and they'll all talk to each other all of them doing small sorts of tasks that get built together into a large application. Although more formally, microservices is really a variation of service-oriented architecture. And for more details about that, you can take a look at this video here. Later, when we look at Kubernetes, you'll see that there's a concept called a pod. And having looked at this video, you'll know that a pod is actually a Kubernetes managed container with its C groups, its name.
I think now it's clear that he mentioned for the C group, name of space, and unit capable, and those are which are the features that are existed or offered in the kernel or in the Linux support, system that is support those things. So the virtual machines, it's work as we mentioned with to create containers and fit some data, some resources for inside those containers to be used separately. Containers are a balance between isolation and overhead of the running isolation application. As we mentioned, it will have some benefits. The first one, isolation, portability, and easy deployment also. The containers, as we mentioned from the YouTube sketches, it will show the ch10 or Agile, namespace, or C groups. Linux will be used for that one. Docker is a popular implementation of a container ecosystem, and there are a lot of YouTube sketches which is it explaining the Docker and how is it works there. The containers orchestration abstracts the resources of a cluster of machine and provides service to containers. A container orchestrator enables containers to be run anywhere on a cluster of machine. This is the orchestration or container orchestration. Schedules and containers to run on any machine that has resources availability, acts like a kernel for combined resources of an entire data center. So now we finished from the data center. We'd like to hurry up a little bit to end with the time. The mainframes, the most important with those slides that the names of the normal PCs or chips inside the PC, it's not similar for the mainframe. يعني في تغيير في أسماء القطع والأشياء الموجودة في المين فريم عن البي سي ايز عن البي سيز. مين فريم is highly performing. احنا ذكرنا انه هو كمبيوتر كبير نفس شاهين اللي موجود في السعودية وفي IBM and others. IBM has the largest vendor. It's too expensive, mostly used for administrative processes. هذا عمليات على مستوى الدولة قد يدخل فيها. مركز المعلومات الوطني أكيد عنده موجود سيرفر مين فريم. لذلك قد تجد في الجهات المهمة جدا على مستوى الدولة optimized for handling high volume of data. طبعا هذا الآن شكل لا الله المين فريم الكونسبت. هناك كان عندنا السي بي يو، هنا لا اسمه بي يو processing unit, memory, input output channels, controlling units, devices, all places and racks. From the devices here, if you are mentioning the devices, as we mentioned that we have CPU control process, but in the mainframe we will use the PU processing unit instead of control processing unit. We are using processing unit. A mainframe has multiple PUs. We do not call them CPUs. We call them PUs. So there is no central process unit. The total of all PUs mainframes is called Central Process Complex, CPS. مجموع ال PUs اللي موجودة في الجهاز we call them CPC. Each book package in the CPC cage في الصندوق الموجودة contains from 4 to 8 memory cards. تحتوي من 4 كل صندوق موجود داخله في ال CPC يحتوي من 4 إلى 8. For example, a fully loaded Z9 mainframe has 4 book packages that can provide up to total 512 gigabit of memory. Disks in mainframes are called DAST, direct attached storage devices, compatible with the SAN in the mainframe. طبعا بعض الانبوت او ديفايسز ممكن يكون مين فريم هنا والثاني موجود في الرياض الكنترولر، يعني موجود مثلا هذا في الدمام، مثلا السيرفر مين فريم في الدمام او انه في الرياض، وفي بعض المستخدمين المين فريم في الدمام. غالبا ما يكون التوصيل يستخدمون الفايبر اوبتكس في عمليات وحدات الادخال الانبوت اند ديفايسز. يعني الانبوت وديفايسز الكيبورد اللي يستخدمونه حتى نضمن سرعه او سرعه الوصول معلومات، يتم استخدام الفايبر اوبتكس تو انتر اور لعرض البيانات اللي ظهرت على السكرينز. Mostly we are using fiber optics. So a control unit is similar to an expansion card in x86. يعني كل ما بيضيف control unit فقط أركبه بلجن مباشرة. It's similar for the expansion cards. طبعا هنا عندنا الآن الchannel type في OSA. OSA connectivity to various industry standard networking technology including Ethernet. هذه طريقة التوصيل اسمها OSA. الطريقة الثانية اسمها FICN, the most flexible channel technology based on fiber optic technology. هذا اللي احنا ذكرناها. انت ممكن تعمل في الرياض او السيرفر في الرياض المين فريم، وانت تعمل في الدمام الكونكتيفيتي الكيبورد والسكرين موجودات في الدمام، بينما السيرفر موجود المين فريم موجود في الرياض. So you are using the fiber optic technology to connect the input and output devices. It could be in many kilometers. الإيسكون similar for الفيكم بس إن المسافات أقل. هو يعتبر الموديل القديم. An earlier type of fiber optic technology almost as fast as فيكم channels but in a shortened distance. ولكن هذا لا يدعم مسافات كبيرة. هذا قد يكون مثلا خلينا نقول 1 كيلو نصف متر، أو عفوا 1 كيلو نصف كيلو، يعني من مبنى لمبنى. This is we are using the ISCON technology. Here just repeated for what's mentioned in the YouTube sketches. The previous ones, many frames of the slides were designed for virtualization from the start. لما صممت للvirtualization من الأساس بنيتها. Logical partitions بما أني صممها virtualizations I have to do some partitions for it. Partitions also are equivalent to separate many frames. A common number of partitions, logical partitions in use of a mainframe is less than 10. هذه الأسئلة أو slides النقاط هذه ترى دائما تأتي في المultiple choices. دائما تختار في المultiple choices. Often when logical partitions run all production tasks while another runs the consolidated test environment. طبعا ويطول الحديث للمينفريم. Sorry for this lecture, it was very heavy, but alhamdulillah we tried to do the best on it because it has 43 slides and it was mandatory for us to end it by today's lecture.